In this training module, you will learn about the Cobra firing system equipment and how to wire the product to the firing system. Please watch this training module as many times as necessary so you feel comfortable with using the equipment. The Cobra firing system is a wireless firing system. There are 4 basic components the Cobra firing system consists of. The controller is the brains of the Cobra firing system and communicates with the modules in the field. The modules are the body of the Cobra firing system. These units are placed in the field and receive communications from the controller. Slats provide more flexibility for product placement and allow for distance between the product and the modules. Slats connect to the modules using either a DB25 or RJ45 cable. We will look at cables later on in this module. And finally, the igniters are the ignition source that lights the product in the field. When the module receives the command to fire, electricity is sent through the igniter and fires the product. You will primarily be dealing with modules, slats, and igniters during your time on the pyrotechnic crew. We will take a deeper dive into how they operate and how you will be using them at illumination. We will look at the 3 module models that you will see at illumination. Cobra is based on 18 cues per channel. The 18M module has 18 cues and 1 channel. The 36M module has 36 cues split between 2 banks of 18 and contains 2 channels, each bank containing its own channel. The 72M module has 72 cues split between 4 banks of 18 and contains 4 channels, each bank containing its own channel. While each model has some differences, you prepare the module for the show in a similar manner. First, unscrew the antenna connector cap on the side of the module. Then open the module by lifting up on the latches on the case. Next, remove the antenna from the lid by pushing in on the tab on the antenna clip and remove the antenna. Then screw the antenna on the antenna connector on the side of the module. The antenna will fold in and swivel so it can be oriented straight up during the show. Next, we will look at the different slats you will see at illumination. First is a 6S slat, which contains 6 cues. Second is an 18S slat, which contains 18 cues. If the slat contains a cover, carefully remove the cover and attach it to the back of the slat until you are done wiring. You will install the cover back on the front of the slat once the wiring is complete. One other slat you may see at illumination, although there won't be very many, is a standard terminal slat. The one pictured here is an 18S version, but there will be some 6S versions as well. I'll demonstrate how to use these before moving on to the other equipment. These slats will not accept a quick plug connector. They will only accept bare copper wire. If the igniter you are wiring has a quick plug connector, you can simply cut the connector off, then expose a short section of bare copper wire. To insert the igniter wires, you should first bend each wire over on itself, creating a loop. This will increase the surface area of the wire in the terminal and allow for a better connection, increasing the chance for good continuity. Install one wire in the red terminal and the other wire in the black terminal. It does not matter what wire goes in which terminal, nor does it matter which terminal, red or black, you install the igniter in first. Once you have finished inserting all the igniters into the slat, make sure the wires are not touching each other, causing a short in the circuit. Now we will have a look at the igniters used for illumination. There will be a few different lengths of igniters used at illumination, including 3 feet, 7 feet, and 10 feet. The 2 ends of the igniter are different. One end contains the match house inside a shroud, which protects the match head. The match head is made of a pyrotechnic compound that ignites when a small electric current is applied. The other end is what you will be working with and contains a connector. The small brass piece on the end of the connector is called a shunt and will be removed prior to insertion into the module or slat. When ready to insert the igniter into a module or slat, you will need to remove the brass shunt by pulling it out from the end of the connector. You can then insert the igniter into the appropriate Q slot on the module or slat. Feed the igniter wire through the open slots on either end to avoid pinching the wire when replacing the cover on the slat. Once you are finished wiring a slat that contains a cover, you will replace the cover by pulling it off the backside and placing it on the front of the slat, making sure you don't pinch any igniter wires in the process. The process of installing an igniter directly to a module is similar. You will remove the brass shunt from the end of the connector and insert the igniter into the appropriate Q. Once all igniters have been installed on a module, you can check continuity to ensure there is a good connection between the igniters and the module. Turn the module on to test mode and allow the module to boot up. Once the module has booted up, you can check continuity by pressing the test button. The Q LED lights will illuminate green for Qs that have good continuity. If all LED lights illuminate green, you can turn off the module and continue wiring other modules. If you notice an LED is not illuminating green but has an igniter installed in the associated Q terminal, please notify the head pyro technician so he can investigate the issue. To check continuity on 36M and 72M modules, the process is similar with one added step. Turn the module on and allow to boot fully. You will notice the module is set to display bank A. To check continuity on all banks, you will have to cycle through each bank. This is done by pressing the Change Bank button on the module. In this case, there is an igniter installed in Q1 on bank B. The module is currently set to display bank A. When we press the test button, there is no continuity showing. Press the Change Bank button to display bank B. Now when we press the test button, you will see there is continuity on Q1 as expected. You will check continuity on all the banks used on 36M and 72M modules. One important thing to remember when checking continuity is make sure people around you are aware you are checking continuity. While extremely unlikely, in the case the process of checking continuity causes a device to discharge, you want to make sure people are clear and not in direct line of fire. Now let's look at how to connect the slats to the modules. We will first look at 18S slats, or slats that contain all 18 Qs for one channel. You will insert the igniters into the slat as previously shown by removing the brass shunt and inserting the igniter into the appropriate Q. Ensure the igniter wires will not get pinched when replacing the igniter cover by feeding the wires through the openings on either end of the slat. Then replace the cover on the front of the slat. You will use a DB25 cable to connect the 18S slat back to the module. There are different lengths of DB25 cables, and you should ensure you are using the correct length for the module you are working with. This information will be available on the station maps you will be provided with the day of the event. Connect the DB25 cable to the 18S slat and ensure the connection is tight by lightly tightening the pins. Do not over-tighten. You will then run the cable from the slat location to the module. The connections for the 36M and 72M modules are either on the side of the module as shown here, or on the faceplate of the larger 36M modules and 18M modules. Expose the DB25 connections by lifting off the protective boot on the side of the module. Ensure you connect the DB25 cable to the correct bank for the channel you are working with. Make sure the connection is tight by lightly tightening the pins on the cable. Once the cables are attached, you will then run through continuity checks as previously shown. Next, we will look at 6S slats, or slats that contain 6 Qs. You will use an RG45 cable, or network cable, to connect the slats back to the module. Open the 6S slat as previously shown by removing the front cover and attach it to the back of the slat. You will see 6 Q slots, numbered 1 through 6. You will install the igniters as previously shown by removing the brass shunt and inserting the connector into the slat. To ensure the wires won't get pinched when replacing the cover, make sure they are placed through the openings on either end of the slat. Once all igniters have been inserted, you will connect the slat back to the module using the RG45 cable. Insert the cable into the slat. Then run the cable from the slat back to the module and plug it into the module. You will see each grouping of 6 Qs has a connector for the RG45 cable. You will find the correct Q strip and plug the RG45 cable into the corresponding connector. Once all slats have been connected to the module, you can check continuity as previously shown. As a reminder, this is done by turning the module on to test. After allowing the module to boot fully, you check continuity by pressing the test button below the 7-segment display. It is important to note that all 6S slats are labeled with Qs 1 through 6. For igniters that need to be installed in Qs 7 through 12 or 13 through 18, you will treat Q1 on the slat as Q7 or Q13, Q2 on the slat as Q8 or Q14, and so on. Here we see the igniter is inserted into Q1 on the 6S slat. The RJ45 cable is now installed in the Q strip for Qs 7 through 12 on the module. When continuity is checked, you will see the LED for Q7 illuminate on the module. It is critical you connect the RJ45 cable into the correct Q strip on the module. Let's look at one more scenario and one final piece of equipment. A 6S slat will be used in this example, but it could be an 18S slat or even wiring directly to a module. As previously done, remove the cover from the front of the slat and place it on the back. The igniter you are working with indicates it should be inserted into Q1. You notice that there is another igniter that indicates it is also installed in Q1, and you notice a comment on the label that indicates the igniters should be installed in series. However, you cannot install two igniters in one Q slot. We will use what is called a breakout board, which allows us to install up to 5 igniters on one Q. The igniters are installed in a similar manner as on other equipment. In this case, there are 2 igniters that need to be installed. Notice the switches along the top of the slat above each of the Q slots. You will see a label on the right-hand side showing when there is no igniter installed, the switch should be down, but when there is an igniter, the switch needs to be up, indicating an igniter is installed. Make sure the switches are set correctly, or continuity will not be established. Now you need to connect the breakout board and the slat. This is done with a harness. The rightmost Q slot is labeled as input, and the harness must be installed in this slot. Then install the other end of the harness into the appropriate Q slot, in this case Q1. Please note you will not be able to replace the slat cover on slats that have breakout boards installed. Breakout boards are small and can easily be forgotten. It is important that during cleanup, care is given to look for these breakout boards to make sure all breakout boards are returned after the show. This has been a very brief overview of the Cobra firing systems equipment. Again, it is recommended that you go through this module as many times as you need to feel confident in working with this equipment. You may encounter some additional types of equipment the day of illumination. If you are unsure of how to operate any equipment, please seek help. There will be plenty of individuals around that can assist you. This concludes this training module. Again, thank you for taking time to become familiar with the equipment we will be using at illumination.